Good afternoon. My name is AJ Thomas, and today I will be talking a little bit about dynamic allocation. Now, what exactly is dynamic allocation? Well, dynamic allocation deals directly with memory. When, of course, we're in reference to computer science terms, usually memory is allocated through static memory allocation. But here we're talking about dynamic. Now, with dynamic allocation, memory is set aside in a heap pile, and when the runtime comes, if that memory is needed, then the user can access that memory and store things in that memory that you didn't know that you would necessarily know that you would need at compile time. Static memory is for compile time, and dynamic memory is for runtime. Now, the memory block for dynamic allocation can be used whenever needed during the program execution or until explicitly deallocating it. Unlike the automatic memory, which is available only inside the function or block, which is static memory, of instructions where it was declared, allowing a program to allocate dynamic storage every time it needs more until the program stops can cause it to eventually run out of available space. This is an obvious problem. If our computer runs out of space, out of memory space, then we can't store any other values. We don't have any room to store anything in any memory addresses if we use up all of our memory space. Now, this is prevented with the two functions that are introduced when dynamic allocation is introduced, and those two are in C++ are new and delete. Now, when you want to, while you're programming, if you want to set aside memory for something in your program, you're going to start by using the new function, okay? And when you use this new function, when you're done with that memory, or when in your program, when you're ready to delete that memory, you end it by using the delete function, okay? If you don't use the delete function, then you could cause things that are called memory leaks, and memory leaks are what lead to the system running out of memory, which is again what we do not want. Now, in C++, we have destructors, which allow us, when we make our constructors, we also make our destructors if we know that we're going to use dynamic allocation to kind of come up and clean up behind us. In C# and Java, they have an interesting thing called garbage collectors, which figure out what's no longer needed in the program while it's running, what's no longer needed, what's no longer being used, and it automatically deletes that, therefore freeing up more heap memory, more memory for your dynamic allocation. Now, I hope that you learned a little bit about dynamic memory allocation with what I just told you, and I hope that you have a great day today.